So here's a very preliminary introduction to a gearbox. So here you see a picture of a gearbox. You're actually going to do some design based on this in a while. But one purpose, not the only purpose, but one purpose for designing a gearbox is to increase or reduce the speed. So what that means is if I spin this little green one 4 times, this red one only goes around once. That's a speed reducer. And what we call the gear ratio is the input turns 4 times per output turns once. So this has a gear reduction, gear ratio of 4 to 1. What's cool about gearboxes, if you design them a certain way, which we will do in this class, you can stack them together so the output of this one becomes the input of the next one. And so then you get 4 to 1 to 4 to 1. It's a 16 to 1 gear reduction. So that's a cool thing about gearboxes. They reduce the speed. So if I have a very fast motor that's running at a fixed speed and I want a slower specific output speed, I can design these gear ratios so that the output speed is exactly what I want. So let's take a look at it. Here you'll see a little YouTube that we've done. So you'll get to see it. Now, I want you to count the green turns, how many times the green one turns until this one goes all the way around. Red one goes all the way around. Should go 4 times around for the red one to go once. Let's go. 1, 2, 3, 4. That was 4 times. So that was 4 times around for that. That's a 4 to 1 gear ratio. Okay, now we're going to go back and count this one, how many times this goes around until this one goes around once. These are stacked. This one will go around 16 times until this one. Back to the beginning again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one turns 16 times. This is a stacked one. These two is one set, 4 to 1, coupled with another set that's 4 to 1. 4 times 4 is 16, 16 to 1. So that's how gear sets work. That's the basics of it. Let's take a look and see. There's a little bit of terminology. I'm going to get that. A little bit of terminology. The pinion gear is the drive gear, is the gear you turn, is the input gear. So those are all the same way to talk about this little gear that we were spinning. Output gear is the driven gear, is the transfer gear, is the gear that gets turned. So I'm used to mostly saying pinion and driven, but often you'll see input and output. Sometimes they'll just be numbers. But you should know that pinion, output, drive gear, input gear. You should be familiar with these terms because you see them used interchangeably. Next, there are some important features of gears. Okay, the most important one is the pitch diameter. Okay, the pitch diameter of one gear plus the pitch diameter of the other gear has to equal the center distance or your gears don't work. Okay, the pitch diameter, if I don't know if I can. Oh, here we go. The pitch diameter is where the two gears actually make contact. Okay, and this is a special kind of gear called an involute gear, and there's an angle that pressure makes contact at that actually drives it. So if this is done very well and it's all put together, these actually roll on each other instead of slide. When they slide, it creates friction, and friction creates heat. Heat makes gears degrade or bind up or lock. So it's really important to get this, to know this pitch diameter. It's just a matter of the gear design and the center distance. And these gears are there's so many gears that are already designed, and there's sets that you can already use, but you have to know what you're doing. You have to use two pitch diameters of the same pressure angle to figure out your center distance, because that will be a shaft and that will be a shaft. And then there's something called the circular pitch. And that, how far it is from the center of one gear tooth to the next. Okay, and if you figure it, and that tells you how many teeth there are. So if you know how many teeth there are in the driven gear, divided by the number of teeth in the pinion, that is your gear ratio. So I know that's all just a bunch of words right now. You're going to get a chance to play with it, kind of practice and get it to sink into your bones. But I wanted you to hear those words. Oh, and then there's also the outside diameter. That's important because the outside diameter has to be side so it doesn't bottom out in this root. And often you'll see bearings on the shaft. In the design that we're going to use, the outside diameter of the gear is actually the surface, the bearing surface, the surface that it rides on. It's what holds it in place. And that is done in industry. It can be done. And so you have to know the outside diameter. So that is your intro to gear boxes.